Yesterday, we were adding and subtracting inequalities, and you were using the same strategies and methods that you learned when we were solving addition and subtraction equations. Well, now we're going to look at solving multiplication and division inequalities. And again, you're going to be practicing those same skills from when you were working with equations. But however, today's work, all of our numbers that we're going to be multiplying by or dividing by are going to be positive, because when those numbers are negative, there's a little bit of a change that has to occur. So as we're working through these today, we'll be practicing those strategies from equations, but tomorrow expect a wee bit of a change. So just like we talked about the addition properties of inequalities and the subtraction properties of inequalities, I want to talk to you about the multiplication and division properties of inequalities. So basically all these properties mean is that as long as you are multiplying both sides of the inequality by the same number, or dividing both sides of the inequality by the same number, the inequality stays true. So this is like that balancing that we've talked about. Whatever you do to the left side of the inequality, you have to do to the right. Whatever you do to the right side of the inequality, you have to do to the left. As long as you keep it balanced, then you are keeping the statement of that inequality true. Let's look at how to solve a couple of these. So I'm going to rewrite my inequality over here on the right-hand side so that I have space to show my work. So say we have 7x is greater than 28. Well, remember when you have a coefficient and a variable, a number and a letter, right side by side like this, that's mathematician's code that those numbers are being multiplied. So 7 times x is going to give us a value that is greater than 28. So the opposite of multiplying by 7 would be dividing by 7. So I have to divide both sides to keep it balanced by 7. So then I'm left with x is greater than 28 divided by 7 is 4. So x is greater than 4. Well, now that we've done this, I need to graph it on my number line. I'm going to use the 4. Since it's greater than, I know I need an open point. So at the 4, I'm going to put an open point. And when I think about what's a number that is greater than 4, well, 8, 9, 11, all of those are greater than 4, and those would be on the right side of the 4 of my number line. So I'm going to shade to the right. And of course, I put that arrow to represent the fact that it goes on and on forever. Now, because I've graphed on my number line, I need to show my check. So I'm going to take the number 7, and I'm going to substitute it into my inequality for my variable and make sure that it makes sense. Is 7 greater than 4? Yes, it is. So I know that that's a true statement. And I know that I then have graphed it in the right way, putting a box around my answer because I know that it is correct. Now let's look at this second one. We've got y over 5 is less than or equal to 30. So from here, I'm going to do the same thing. Y is being divided by 5. The opposite of dividing by 5 would be multiplying by 5. So I'm going to multiply both sides of my inequality then by 5. On this left side where my variable is, these cancel out. We end up with y over 1, which is just y. 30 times 5 is 150. So y has to be less than or equal to 150. So on my number line, because I have a less than or equal to, it is a closed point. And when I think about something that is less than 150, 100, 90, all of those numbers would be on the left side of 150 on my number line. So I'm going to shade to the left. And of course I'm doing that arrow to make sure that we know that it goes on forever. Now I'm going to do a check. I shaded the 145, so I'm going to substitute that in for my variable. 145 is less than or equal to 150. Yes, that's true. So I can be relaxed in the fact that I have graphed correctly.